board, live. 5, 3, 22. So today we're going to be solving exponential and log equations, okay? Okay, we're going to be solving exponential and log equations. Okay, so let's just start at the beginning. So one of the things I know is if I have the same base, if I have the exact same base, then these two are automatically going to be equal. It just makes sense, doesn't it? If the base is the same, so if I have 5 to the 3x and 5 to the x plus 2, really what we're looking at is just 3x equals x plus 2. But it's because the bases are the same. It actually makes sense, right? It's pretty obvious. So then, if the bases are the same, we just solve for the exponents. Minus x, call it 2x equals 2. Divide by 2, and x is equal to 1. Okay, now we can check that problem. If we check the problem, it should make sense. If I plug the 1 in, I have 5 to the 3 times 1 equals 5 to that 1 plus 2. And sure enough, we get 5 to the third plus 5 to the third. You get 125 equals 125. So it just makes sense, right? You don't need to check it, but if you have the exact same base, then you can cancel out the bases and solve the exponent. Okay, thumbs up, pretty easy. Same base, the exact same base, cancel out the bases and solve. So if that's true, tell me about number 2. What do you know? But we can make them. Caden, what do you see?
8 can be base 2.
Everybody agree with that?
Yeah.
So let's rewrite my 8 as 2 to the third power. Okay? And once we make them the same base, then we can go back through and do the exact same thing. I can cancel the bases and have a 3x plus 2 equals 3, right? And just solve.
Wait, that's weird though.
3x equals 1. Divide by 3, and x is 1/3. Okay? How am I doing? Yeah, I will. I'll wait. So if you can make them the same bases, it's pretty easy. Make the same bases, cancel out, and solve for x. But example 3, you cannot make them into the same base. So we're going to use logarithms. Okay? Whenever you want to solve for an exponent, you need to use logarithms. So I'm going to change it from exponential form into log form. Okay? So let's rewrite it. So we rewrite this problem as log base 3 of 5 equals x plus 2. Okay, take a look at it. If you're confused what I did, look at the board.
I understand.
Okay, just see how the board will transpose it from exponential log form. Give me thumbs up if you guys see what I did. Now, we've got our fancy calculators, right? And if we have the old calculator, then bummer. But you could do the change of base. But if you have the fancy calculator, the good ones, we can do this. So go to your math button, right? So if you don't have a calculator, there's probably left. All the old ones left. Let's see. Okay, it's good for you guys. You left me the old ones, huh? No problem.
There's still some from Bart. I love the new one.
I know. Valeria, can I borrow yours real quickly?
Yeah, I don't know.
So if you have the new calculator, you just go to math, right? I'm going to go to log base 3 of 5, and I get an answer, about a 1.46, okay? So you have about a 1.46. If If you don't have a new calculator, we just do it the old-fashioned way, doing the change of base. Remember I showed you that yesterday. And I would just go, oh, I need new batteries on that one. Okay, I would just do the change of base. I don't know if you remember the change of base, but you can go log 5 divided by log 3. That'll work. And I get the same answer, right? So, old calculator, do the change of base. New calculator, just use the fancy button. Okay, and that equals an x plus 2. And then I'm going to subtract. Go minus 2, and I should have a negative 0.454. Negative 0.54. 1 minus 2. Yeah, but negative 0.54. So I did my calculator. I got a 1.46. I went minus 2, I got a negative 0.54. Thumbs up on that? Okay, now, example 4. Before we do any log or any fancy stuff, let's get rid of the 12, right? It's 12 times that. So I would say let's first just divide by 12. Divide by 12. Okay. And all my batteries are going low on these. Need to replace the batteries, huh? Oh, I'm good. Thank you, Ariel. You're awesome. So I'm just going to go 400 divided by 12. And for accuracy, I'm going to leave those numbers in my calculator, okay, for accuracy. So I've got a e to the 2x equals a 33.3 repeating, or 33 to the third. Well, I need to change this to log form. So we change to log, so change to a log. So I'm going to go log base e of 33.3 repeating equals 2x. Now, log base e, that's a special button, isn't it? That's your ln. So log base e is ln, natural log, of 33.3 equals my 2x. Okay, everybody good on that, right? ln. And then my calculator, even my old calculators will do that. I'm just going to go, okay, ln of 33.333. Okay. Well, I just put a bunch in there, right?
Oh, okay.
Yeah. So I get about 3.5. I rounded at 3.51, maybe 3.51. We're going to put up here. So I've got 3.51 equals 2x, and then it's easy. Divide by 2. Divide by 2, right? So divide by 2, divide by 2. And I get an answer of about 1.75, approximately. Pretty easy? You guys, you okay with this? Yeah, I sure can. And I'll wait for you, okay? And we'll turn the page in a minute, okay? So not too bad. I mean, we're just basically using our log rules. So logarithms allow us to do exponents. That's the whole point. Logarithms are really important for us because you can't solve for x if it's in the exponent unless you have logarithms. They're pretty handy, okay? Okay, and log equations. Well, log base 4 of 5x, you cannot use your calculator because of the x, but we can solve it. So let's change this one. Let's change to exponential. So I'm going to change that to my exponential form. And we're going to do this process. We're going to take it from here to here. Okay? So there's my base of my exponent, right? So we're going to rewrite it in exponential form. So we're going to rewrite this as 4 to the third power equals 5x. Okay? And then 4 to the third power is 64. You can use a calculator, but it is 4 times 4 is 16 times 4 is 64. But you can try that calculator. Equals 5x, right? Divide by 5. Divide by 5. And let's see, 64 divided by 5 is 12.8. Okay, how am I doing? Now, before we go any further, let's make sure we have a rule. Okay, a rule, okay? Before we go any further, log of any base of x always has to be greater than 0. If it's negative, if x is negative, if this is negative or 0, if this is negative or 0, we're in trouble. Okay, before we go any further, I'll just show you what I mean. If I took log, I just want you to see it, log of 0, undefined. The reason, and it's worth noting, the reason is this, okay? Just take 2 as any base. 2 to some power equals 0. Just take it.
Are you going to do this in the test?
What? You got to be careful. You'll find it with your calculator. You'll know. If this number is negative, it could be negative, but it won't make it 0. It just makes it a small fraction. It will never equal 0. So logs of 0 can't work, and logs of negatives can't be 0. Same thing. So you cannot do log of a negative, and you can't do log of 0. So even if I went log of, say, negative 2, same problem. So this has to always be greater than 0. Thumbs up?
Yeah.
If it doesn't work, it won't work. Okay, so example 3. So example 3 is a lot like, let me flip, or example 6, I'm sorry. Example 6 is a lot like example 1. If the bases are the same, we can get rid of it, right? See, the base is the same? So the same thing here. Log base 3, log base 3. If the bases are the same, you can just get rid of it and go 2x plus 4 equals a 5x minus 3. And then it's easy, right? Just solve for x. Minus 2x minus 2x. I've got a 4 equals a 3x minus 3. I'm going to go plus 3 plus 3. 7 equals 3x. Divide by 3 and I get 7/3. Well, what's that? 2 1/3. Same thing. Now, example 7 is the good one. Example 7. What we're going to do is this. We are going to combine these two. We're going to combine them. How do we combine them? This is what we learned yesterday. We need to combine them. Make it a single log. You see this plus? We're going to bring these, yes, totally right, Giselle. So I'm going to rewrite as log base 2 of x times x minus 3. I just put the brackets inside the brackets. So there's my invisible times, because she was right. Giselle said it's multiply, so if you see plus, you bring them together as times. All right, we learned that rule yesterday. See the plus brought together as times. Now, let's change this to exponential form. So I changed this to exponential form. I'm going to take it from log form to exponential. So we're going to have 2 to a 2 power equals this. We're going to change it to our exponential form. So we're going to rewrite this as 2 to the 2 power equals x times x minus 3. All right, now it looks like a little bit of algebra. I can do that. I got that. I got this. So 2 squared is 4, and I'm going to distribute x squared minus 3x. Maybe I need to factor. I think so. I need to factor. So to factor and find zeros, I need to find zeros. I'm going to bring the 4 over so I can find my zeros. So I'll subtract 4, right? Go minus 4, so 0 equals x squared minus 3x minus 4. I just subtract 4 to bring it over, correct? Correct? Okay, factor. Well, we're good at factoring. X times x. What times what makes 4?
2.
2 and 2. Give me another combination.
4 and 1.
Ah, how about a negative 4 and a positive 1? Isn't that a great combination? I've got my mini equations, x minus 4 equals 0 and x plus 1 equals 0. And if I solve this, I get x equals 4 and x equals negative 1. Right, but wrong. Right, but wrong. I'm going to throw one of these out. The negative. Everybody agree? Throw out the negative, because if I tried to plug in right here, log base 2 of negative 1, I'd get an error, so I throw out the negative. Okay? How's that? Thumbs up? Okay, so homework. We got lots of time. You guys want to take a little break? Let me put down the homework, take a little break. Okay, so homework first. Let me write that down. Page 161, 1 through 11, all. And I'll stop my recording, okay? So if we take a little break, we do a little brain break, and we walk around the school, let's not get lost. Let's not get lost.